So here's another method that I think we'll find out will work better for the challenge. And that's the strategy called substitution. So let me remind us of what our two equations are. The sum is supposed to be 14, so that's x plus y equals 14. And the difference is supposed to be 2, so x minus y equals 2, and that's our system. Well, this is what we do in order to use the substitution method. First off, we need something that we are able to substitute. And in order to do that, what we want to do is isolate one of the variables in one of the equations. It doesn't matter which variable you isolate, and it doesn't matter which equation you use to isolate it. You need to get one variable by itself in one of the equations. I think what I'm going to do is add y to both sides of the second equation. And that'll allow me to rewrite the second equation like this. You'll notice it was x minus y, so by adding y, I've gotten the y off of that side, and now it's going to show up on the other side. So I'm going to have x equals 2 plus y. So now you can see I isolated this variable x. And the way the substitution method works, it's exactly what it says it is. We're going to substitute from one equation into the other equation, and what we're going to substitute is this. We know that x has to be equal to 2 plus y, so I'm going to go into the other equation, and where I see an x, I'm going to replace it with 2 plus y. Alright, so we've rewritten one of the equations so that we had a variable isolated, and now we're substituting it into the other equation, and here's what the other equation is going to look like. Instead of writing this x, I'm going to write 2 plus y because I did the substitution. Now I just keep going, minus y equals 14. And if you just stop for a second and look at this equation, you'll notice there isn't an x to be found here. Only y is left in the equation. And hopefully by now you're pretty darn good at solving single equations that only have one variable in them. So it turns out here that y minus y is 0. Oh, wait a minute, I just miswrote something. Sorry. I was going to say something crazy looked like it was happening there. That is supposed to be a plus, not a minus. Okay, this makes much more sense now. So 2 plus y, of course, is 2y, and that's supposed to equal 14. So I'm just solving for y. I'll subtract 2 on both sides and get 2y equals 12. And I'll divide both sides by 2 and get y equals 6. If you remember, back on the other page, that agrees with the solutions we got using our first two methods. Okay, but now that we found y, we still have to go back and find x. And here's one of the nice things about substitution, is if you take the place where you had one of the variables isolated and use that to solve for the other variable, it's always very easy to do. So we know y is supposed to be 6, so I just take this equation and say x equals 2 plus 6, so x equals 8. Okay, so we solved the system using substitution, and do we think that would be a good method to solve our challenge? I think it probably would be. I think, you know, we'll have x plus y equals that first ugly number, and x minus y equals that second ugly number, and we could do this same sort of substitution, and I think it would work out quite nicely. Okay, and lastly, we're going to talk about this thing called the y to y substitution. As I said a moment ago, this really isn't a different, it's not a different strategy from substitution, it's just sort of a special case of substitution. And in this particular case, it's going to make us do a little bit more work, so I don't see why you would use this method over just plain old substitution to solve it, but we want to talk about this method anyway. So in order to do y to y substitution, what that means is, first of all, you need to get y by itself in both equations. Now, it doesn't necessarily have to be y. I guess it could be any of the variables, but as long as we're calling it y to y substitution, we're going to get both of these y's by themselves. In the top equation, it's very easy to get y by itself. I would just subtract x on both sides, and that top equation is just going to become y equals 14 minus x. Okay, so I got the y by itself. Second equation is going to require just a little bit of extra work. Again, I'm going to subtract x on both sides. But now you'll see I'm left with negative y equals 2 minus x. And I want that y by itself. So what I have to do here is divide through by negative 1, which is just going to change the signs on everything. So I get y equals negative 2 minus x. Well, all the y to y substitution means is now we're going to take this expression, which we know is equal to y, from this equation, and we're going to substitute it into the other equation for y. So we're going to say that negative 2 minus x equals 14 minus x, and then we're going to solve this equation for x. Of course, I made another sign mistake here. This was a negative x, and I was dividing it by negative 1, so of course that is supposed to be a plus there. Alright, now I solve for x. Perhaps I'll start by subtracting x on both sides and getting negative 2 equals 14 minus 2x. And then I'll subtract 14 on both sides and get negative 16 equals negative 2x, and then I'll divide both sides by negative 2 and get that 8 is equal to x. Again, I'm not done yet. I have to go back and substitute for y. I could use either one of these equations to do it. It doesn't matter. I'll get the same thing, assuming I've done everything correctly. So I'm just going to use this one right here. Y equals negative 2 plus x, but I already know what x is. It's 8. So again, I get y equals 6. As I said, there's really nothing special in this particular method of substitution. I think of all our choices, strategy 3 is going to be the best method to solve our challenge problem up here. Two numbers whose sum to this ridiculous number and whose difference is this ridiculous number. I will leave it to you to try to solve that challenge problem on your own for now. Good luck.